Electricity. Lesson preview. Cells and their types. Electric current. Electric circuit. Elements of an electric circuit. Electric switch. Conductors and insulators. These days we make use of electricity lesson preview extensively in our daily lives. We use electricity throughout the day. We use electricity to light our homes, offices, shops, etc. Various appliances like fans, mixers, toasters, washing machines, juicers, televisions, computers, and microwave ovens all run on electricity. At times, the electric supply may fail or there may be power cuts in certain areas. In such situations, we use a torch to provide light. When we switch it on, the bulb present in the torch lights up. How does the bulb light up? The torch has an electric cell which provides electricity to the bulb. Cells and their types. Electric cells. Electric cells are used in alarm clocks, watches, cameras, etc. An electric cell is a source of current or flow of electricity. It has a small metal cap on one side and a metal disc on the other. A cell has two terminals marked as plus and minus. The metal cap is the positive terminal and the metal disc is the negative terminal. The chemicals stored in the cell produce electricity. A cell produces electricity by a chemical reaction that changes chemical energy into electrical energy. When the chemicals in the cell are used up, it stops working, and we need to replace it with a new one. Two or more cells connected together form a battery. Many other types of electric cells are available. The car battery used in cars is big and heavy. It has usually 6 cells inside it. It can supply more current than a single dry cell. The battery can be used again and again after recharging with the help of an electric charger. Smaller cells used in a mobile phone can also be recharged and used repeatedly. Button cells. Button cell is a small single-cell battery shaped as a squat cylinder. It is used in small electronic devices such as wristwatch, calculator, hearing aid, etc. Some button cells are single-use throwaway cells, whereas some can be recharged again and again. Solar cells. Solar cells convert solar energy directly into electrical energy. A solar panel contains many solar cells connected together. Human-made satellites in outer space derive electrical power for their various functions from the numerous solar cells mounted on their solar panels. Solar cells in solar panels provide electricity to buildings, street lamps and water pumps in remote areas where there is no power supply. Activity. Take a torch. Remove the cells. Switch on the torch. Does the torch glow? It does not glow because the cells are necessary to make the torch glow. Remove the bulb from the torch. You will see a thin wire fixed in the middle of the glass bulb. When you switch on the torch, you will find that it is this wire which glows. This is called the filament of the bulb. You will notice that the filament is fixed to 2 thicker copper wires which provide support to it. One of these wires is connected to the metal case of the bulb and the other is connected to the metal tip at the bottom at points called terminals. The base of the bulb and the metal tip of the base are the 2 terminals of the bulb. All electric bulbs are of the same design. The torch has a body, bulb, slide switch, and electric cells. A torch consists of a simple electric circuit in which 2 or more cells are connected to a torch bulb through a sliding switch. When the torch is needed to provide light, the sliding switch is closed by pushing it forward. The metal strip moves beneath the switch so that the circuit is completed and the bulb of the torch lights up. When the torch is not needed, the sliding switch is opened by pushing it backwards so that the circuit breaks and the bulb is turned off. Inside view of a torch. Reflector. Slide switch. Plastic casing. Bulb. Electric cells. Electric current. How do you think the bulb glows in a torch when the wires are connected by the movement of the sliding switch? Something which has energy must be flowing in the wires, otherwise it cannot produce light and heat energy in the bulb. We call this electric current. The electrical energy of electric current gets converted into light and heat energy when the current flows through a bulb. The electric current flows from the end of cell marked plus, positive terminal, through metal wires to the end marked minus, negative terminal. Electric circuit. A cell kept close to a bulb will not make it glow. So, to light up a bulb we need a connecting medium. When we connect the two ends of a cell to a bulb using copper wires, the bulb glows. This happens because copper wires provide passage to the electric current to flow from the positive terminal of the battery to the negative terminal through the bulb. Such a path of an electric current is known as an electric circuit. The complete path of the flow of electric current from one terminal of the cell to the other through the bulb is known as a closed electric circuit. What happens if we disconnect or cut off one of the wires? The bulb will not glow. This is because the current is not able to flow through the wires. Such an electric circuit is said to be broken or open. Closed circuit. Open circuit. Electric circuit with a switch. In an electric circuit, the direction of current is from the positive to the negative terminal of the electric cell. Elements of an electric circuit. The components of an electric circuit are known as the elements of a circuit. They include cells, battery of cells, switches, bulbs, etc. We use these symbols to represent them. You must have seen that sometimes a bulb does not glow even if it is connected properly to a cell. This happens when the bulb is fused. The main reason behind the bulb getting fused is that the filament has broken. This means that there is a break in the path of current between the two terminals of electric cell, battery of cells, switch, electric bulb. Activity. You will need two pieces of plastic-coated wires with a little bit of plastic removed from the ends, a screwdriver, a tape, a battery, a bulb with holder. Procedure 1. Tape one end of the wire to a battery terminal. 2. Connect the other end of the wire to the bulb holder. What happens? Does the bulb glow? Connect the wires in different ways as shown in the diagram. It will be seen that the bulb lights up only when the circuit is complete. Electric switch. Switches help to control stopping and starting of current flow in a circuit. Activity. Making your own switch. You will need board pins, paper clip, cardboard/thermocol, 2 wires. Take the cardboard/thermocol and insert a board pin into the ring of a paper clip as shown in the diagram. Ensure that the safety paper clip is free to move around. Now, fix the other board pin in such a way that the free end of the paper clip can touch it. The paper clip acts as the switch. Complete the current by connecting an electric cell and a bulb. When the end of the paper clip touches the board pin, the bulb will glow. Now rotate the paper clip so that its free end may not touch the board pin. Does the bulb still glow? No. When the paper clip touched the 2 pins, the circuit was closed. In this position, the switch is said to be on. When we rotated the clip so that it could not touch the pin, there was a gap between the 2 pins, and the circuit was not complete. The switch is said to be off. Thus, we can say that the switch is a simple device that completes the circuit or breaks it. All the switches that we use in our homes work on the same principle. Conductors and insulators. Some materials allow electricity to pass through them whereas others do not. The materials that allow electricity to flow through them are called conductors. Materials which do not allow electricity to flow through them are called insulators. Activity. To test which substances allow electricity to pass through them. Take different substances/materials like matchsticks, thread, nail, steel spoon, cloth, eraser, scale, coin, an iron nail, aluminium, spoon, and glass bangle. Connect the material to be tested between the two broken ends of the wire. If the bulb glows, the substance is a conductor. Note down your observations. When the bulb glows, it indicates that the material being tested allows electric current to pass through it, and such material is known as a conductor of electricity. The bulb does not glow when the material being tested does not allow electric current to pass through it. Such material is known as insulator. From the findings in the above activity, classify the materials as conductors or insulators. All non-metals except graphite are insulators. Some conductors of electricity are silver, gold, aluminium, iron, acids, and tap water. Some insulators are cotton, wood, rubber, plastics, paper, glass, and dry air. Both conductors and insulators are important for us. Switches, electrical plugs, and sockets are made of conductors. The outer coverings of switches, plugs, sockets, and other parts of electrical appliances which we may touch are made of insulating materials such as plastic or bakelite. The wires we use in our homes to run a fan, toaster, mixie, washing machine or oven are all coated with an insulating material such as plastic. This saves us from getting an electric shock. The electricity we receive in our homes is generated by large generators in power plants situated far away from the city. It is brought to our house through thick wires. Caution: you should never play with or handle electric wires, switches, and electrical equipment at home. Never do any experiment with domestic electricity. It can prove to be very dangerous.